Hello. I guess my voice is audible. I guess my voice is audible. The students of the country. Good evening to one and all. There are just 1 or 2 minutes left. We are ready to live session. This is the fourth day. Thank you so much for joining the live streams of class 9th standard CBSE live stream. For the days we can go ahead for class 10th standard, 11th standard and 12th standard as per the CBSE curriculum. We can wait for just a moment, then we can start streaming line. I guess my voice is audible to everyone. I guess my voice is clear. Just let me cross check. Hello. Uh, is my voice is audible? Is it clear? Yes, I guess you can see the presentation also. We will start now. Welcome to Physics Cartoon Camera. The title itself, Cartoon Camera. So in Physics Cartoon Camera, you can observe that the recording classes of class 6th standard to MSc, science facts, laboratory experiments, hands-on experiments, jobs in physics, invited talks by physicists, practical applications in our surroundings, live stream for class 9th standard to 12th standard CBS and icse through podcast. So this podcast every day, Monday to Saturday, night 10 to 11 p.m. So all over the country students can able to attend. The main purpose of the live stream, I'm promising to explain the physics in a practical way where the children can understand very easily and they can write to academics in examinations. So I'll start from now. The second chapter we are going to start today, that is force and laws of motion. Force and laws of motion. Here we will see Yes, we will proceed. So what we learn this chapter? Definition of force, effects of force and types of forces, laws of motion, Newton's first law, Newton's second law, conservation of momentum, Newton's third law. So we'll see that. What is force? Generally the concept of force, yes, children might be thinking a different way. Yes, I'm force, I have some force, something kind of like. Now what is force exactly? Force is nothing but push or pull on an object. Push or pull on an object is called as a force. If you pull the object or push the object, yes, however, it's called as force. Okay. Now, what force can do the best? What force can do? Yes, if you push a ball, yes, it starts move. If you push against the ball, it stops. If you push at an angle to the ball's motion, you can change the direction of a motion. If you apply the balanced force, you merely squeeze the ball. So the force can do in a different types of actions. Yes, whenever a ball is at rest, you push it. Yes, due to the force it moves. The ball is moving. You can apply the force. You can able to stop it. Again, ball is moving. You put a hand over there. It will change its direction. Generally cricket match. He is changing the direction of a ball while applying the force. You apply the force of an object like a balloon or something, or you can squeeze it. So the shape itself changing. So these are all the effects of force. Okay. Now forces are two types. One is balanced force, other one is unbalanced force. So what is balanced force? You can see in this picture there is a tug war. In this tug war, you can see right hand side, left hand side, both the people are applying the same force, which means 300 newtons. So the same force which is applying by the persons, then they are at stable, which means balanced. So that is balanced force. In another way you can see one of the party is applying the more force than the other party. So a rope will move where the force is more. This kind of force we can call it as unbalanced force. Balanced force and unbalanced force. Hope it's clear. The concept of force. Next, you can see if the resultant of all the forces acting on a body is zero, the force are called balanced force. Now, they do not move the object. Due to this balanced force, they do not move the object. They can change the shape of an object. These two the balanced force can do. Okay. Next, unbalanced force. If the resultant of all the forces acting on a body is zero, the forces are called unbalanced force. Generally in the park, children will play seesaw. Yes, that is exactly unbalanced force. The plank moves due to unequal forces from both the ends. Now, Galileo perspective. As per the Galileo perspective, there is a slope. If ball comes down, what happens? Speed will be increased. Now there is a vertical slope. You can push the ball. What happens? Slowly the speed is decreasing. While it's reaching top, it will be decrease. Next, there is no slope. There is no slope. Does the speed change? We will see in this chapter what happens. Now, you can see this Galileo perspective. There are three kinds of pyramids over here. One is a ball is at initial position. Once if you leave it, yes, it comes down, and in the final position you can see slantaneously it's tilted top. So it will reach some extent way, it will be stopped and it will come down. In second diagram you can see it will reach some extent way. Okay. It will reach some extent way. Then the third portion. If you place an object over there, we don't know where it ends. We can't find out until energy keep on moves. Yes. Now, what is inertia? You see here, this gentleman is pushing a very big rock. Is rock can move? Is rock can move? I feel it's difficult. He can't push it. So the stability. There is a concept here, stability. We can understand what is inertia exactly now. You can see this person is standing in a bus. Suddenly bus moved. If suddenly bus moved, what happened? He falls backward direction. Yes. This is inertia at rest. Bus is at rest, of course. This person also at rest. Now suddenly bus moved. What happens? He falls backward direction. So this is inertia of rest. You can see here a driver is driving a car. He hit the wall. What happens? He falls forward direction. That is inertia in movement. Inertia in movement. Now, what is Newton's first law? A body at rest will remains at rest, and a body in motion continue in motion in a straight line with a uniform speed, unless it is compelled by an external force to change its state of rest or of uniform motion. Again repeating. I'll say in another way. The first law of motion we can call it as inertia until unless applying a force, a movable object or stationary object in the same position. I'm writing over here. Until unless applying a force, a mobile object or stationary object in same position. Okay, in same position. So this we can call it as inertia. All right. So shall I proceed? Yes. Yes. Inertia is the natural tendency of an object resist a change in its state of motion or of its rest. The mass of an object is the measure of its inertia. Now let's say there is an activity. Make a pile of similar carom coins on a table. Attempt a sharp horizontal hit at the bottom of the pile using another carom coin or the striker. If the hit is strong enough, the bottom coin moves out quickly. Once the lowest coin is removed, the inertia of other coin makes them fall vertically on the table. Okay, we will see what happens. Why does only the lower coin get detached from the deck and not all? This happens due to inertia of rest possessed by the coins. All coins are at rest initially, and when the lowermost coin gets struck by the striker, its inertial state changes from rest moving, while other coins stay at rest. Hence, only the lower coin gets detached. Alright. Next, why does the coin go away with the card? You can see, take a small glass and put a paper, cardboard sheet, and top of that you place one 5 rupee coin. Just to give a one strike, cardboard sheet will come out of the glass and coin will exactly falls down inside of the glass. So this is also the example of inertia. Place a water-filled tumbler on a tray. Hold a tray and turn across as fast you can. We observe that water spills. Why? We will see. Initially, the state of motion of a tumbler, tray and water are at rest. As soon as we flip the tray, the tumbler, which is in immediate touch of the tray, changes its state of motion to moving, but the water could not change its state of motion. Hence, it spills out of the tumbler. Next, let's see what you understood. Yes. Which of the following is the more inertia? A rubber ball and a stone of a small size. Rubber ball and stone. Audience, can you give your poll? Yes. We will see what the comments over here. Yes, most of the people are saying stone. Exactly correct. Next, a bicycle and a train. Bicycle and train. Let's see. That is train. Yes, train is a more mass. Next, 1 rupee coin, 5 rupee coin. Which one? Obviously 5 rupee coin. Next. Now there is a small assignment to all of you. Write the 3 examples of balanced force and unbalanced force. Define inertia. Write 3 examples of inertia in general life. So these questions, in my description there is an email ID. You can answer, you can post it. I'll verify it. Next, what is momentum? What is momentum? You can see this wonderful picture. He is applying force. There is a mass of an object which is constant. If you apply the force, mass is constant, acceleration is increasing. With less force, less acceleration, more force, more acceleration. If you apply the more force, you have still more acceleration. So F is directly proportional to A. So M is a constant now. So F is equal to mass into acceleration. So the rate of change of momentum of a body is directly proportional to applied force and takes place in the direction where the force acts. Okay, the force is directly proportional to change in momentum by time taken. Now, mathematical formula of second law of motion, F is equal to mass into acceleration. Let's say, suppose an object of mass m is moving along a straight line with initial velocity u. Then uniform accelerated velocity v in time t. Now you can see F is equal to ma. How we can write it? How we can explain in details? Second level says that F is equal to mass into acceleration. Mass into acceleration. So as you know that acceleration A is equal to v minus u by t. Now you can substitute here F is equal to m into, on the place of A we can substitute final velocity minus initial velocity by time. Okay, so F is equal to m into v minus m into u by t. So the the product of mass into velocity, we can call it as momentum P. Okay. Yes. Let me see what you understand. Now there is a question which would require a greater force accelerating a 2 kilograms mass at 5 meters per second square or a 4 kg mass at 2 meters per second square. The question here, which would require a greater force accelerating a 2 kilograms mass at 5 meters per second square or 4 kg mass at 2 meters per second square. For this, there are the two masses over here. As you know that F is equal to m into A. So here the 2 kg mass and 5 meters per second square are 4 kg mass into 2 meters per second square. So which one is greater? 5 into 2, 10 newtons of force. 4 into 2, 8 newtons of force. So finally 10 newtons is greater than 8 newtons. So F1 is greater than F2. Hope it's clear. Next, F1 is greater than F2. Next, a constant force acts on an object of mass 5 kilograms for the duration of 2 seconds. It increases the object's velocity. It increases object's velocity from 3 meters per second to 7 meters per second. Find the magnitude of the applied force for a duration of 5 seconds and what would be the velocity of an object. So this is the question. I'm repeating. A constant force acts on an object of mass 5 kilograms for a duration of 2 seconds. It increases the object's velocity from 3 meters per second to 7 meters per second. Find the magnitude of the applied force for the duration of 5 seconds. What would be the velocity of an object? So here, whenever this kind of question, students always remember, read the question and find out the given data. The first step is given data. What is given data? Which means what they are given in the question. An object of mass 5 kg with the duration 2 seconds. Okay, it increases the velocity from 3 meters per second to the final velocity 7 meters per second. Okay, find the magnitude of the applied force. Find the magnitude of the applied force duration of 5 seconds. Again t is equal to 5 seconds, which means F value we have to find out. What would be the velocity of an object? We will see. As you know that F is equal to mass into acceleration. Okay. So acceleration nothing but V minus U by T. Alright. We will see in details. Now you can see object 3 meters per second, which is initial velocity. Final velocity will be 7 meters per second. Now the force applied over here 2 seconds of mass 5. Now F is equal to m into A. A in the sense of rate of change of velocity, which means V minus U by T. M into V minus U by T. You can substitute over here. So F is equal to mass M how much? 5 kilograms into V minus U by T, which means 7 meters per second minus 3 meters per second by 2, which is 5 into 4 by 2. So 10 newtons. 10 newtons. Now what they're asking extension? If the force was applied duration of 5 seconds, now the same 10 newtons of force applied for 5 seconds. Now V is equal to u plus a into t, which is u plus f by m into t. What is u value? 3 meters per second, plus f value how much? 10 by m value 5 into time t value 2 seconds. So 5 2s are 2 into 2 4, 4 plus 3. Now here f value 10, mass m value how much? 5. Time t value here 5 seconds. Yes, 5 into 2 10, 10 plus 3 13 meters per second. So that is the velocity of an object. Yes. The audience, any questions? Any questions? Yes, you can email me. And who not subscribed, subscribe the channel. You will get automatic live updates. Yes, I'll proceed further. Next. Yes. 10 newtons and 13 meters per second is the answer. Next. A motor car is moving with the velocity of 108 kilometers per hour and it takes 4 seconds to stop after brakes are applied. Calculate the force exerted by the brakes on the motor car if its mass along with the passengers is 1000 kg. Yes, answer this question. Yeah. Now option A 3000 newtons, option B 7500 newtons, option C minus 3000 newtons, option D minus 7500 newtons. We can see how we have to solve the answer. The initial velocity of a motor car, they given that 108 km per hour. Now you can see in this question, it takes 4 seconds to stop. So all the units must be in the same. So initial velocity u is equal to 108 km per hour. So we need to convert into meters per second. As you know that 1 kilometer per hour is equal to 5 by 18 meters per second, which means u is equal to 108 into 5 by 18. If you do that, you will get approximately 30 meters per second. Now it takes 4 seconds to stop after the brake apply, which means after brake apply, motor car will be stopped. That velocity is final velocity, that will be 0. After stop the vehicle, obviously speed will be 0. Yes. Now that is final velocity v is equal to 0 meters per second. Mass of a car they have given, that is 1000 kilograms, that we are mentioning over here. Time takes to stop the car, that is 4 seconds. Now we need to apply. F is equal to mass into acceleration. F is equal to mass into acceleration. So which means mass into acceleration in the sense of rate of change of velocity. Final velocity minus initial velocity by time. Alright. So mass how much? 1000 kilograms. Final velocity 0 minus initial velocity 30 by 4. So approximately how much? You can say 7, 28 and 5 approximately. So which means 7.5, let's say here. So 7.5 into 1000, which means 7500 newtons. 7500 newtons, which is the force applied over here. Next question. I guess, hope you're understanding immediately after the theory. Once we solve the numericals, students can understand easily and you won't get scared about the numericals. So exact answer is minus 7500 newtons. Next question. A force of 5 newtons gives a mass m1, an acceleration of 10 meters per second square, and a mass m2 with an acceleration of 20 meters per second square. What acceleration would it give if both masses were tied together? Repeating. A force of 5 newtons gives a mass m1 an acceleration of 10 meters per second square and a mass m2 and an acceleration of 20 meters per second square. So what acceleration would it give if both masses are tied together? So how to answer this question? Option A 20 meters per second square. Option B 3.4 meters per second square. Option C 6.67 meters per second square. Option D 6.12 meters per second square. We will see what is the right answer and how to do this. Now you can see the force of 5 newtons gives a mass m1 an acceleration 10 meters per second square and a mass m2 with an acceleration 20 meters per second square. What acceleration would be the masses? Which means, let's say a1 is equal to 10 meters per second square, a2 20 meters per second square, F is equal to 5 newtons. We need to find out mass. So as you know that F is equal to mass into acceleration. Yes. Now mass m1 how much? 0.5 kg. Mass m2 0.25 kg. Clear? How we got it? As you know that m is equal to F by A. F value how much? 5. Yes, the first case F by 10, which is mass m1, let's say 0.5 kilograms. At the same time 20 by acceleration over here. No, here mass m is equal to force by acceleration, which means 5 by 20 is equal to 1 by 4 is equal to 0.25 kilograms. So m1 m2 we got it. Both the masses tied together. If both the masses tied together, how much? That is m is equal to 0.75 kg. For this, what is acceleration? A is equal to again force by mass, which means 5 newtons by 0.75, it comes as 6.67 meters per second square. Clear? Yes. We'll proceed now. Exact answer is 6.67 meters per second square. Yes. Now this type of question they'll ask. The velocity time graph of a ball mass 20 grams moves along with the straight line on a long table. So you can see that velocity time graph they have given. So here velocity noted as 20. What is 20 here? Centimeters per second. They given a logic over here. 20 centimeters per second, but the time will be in seconds only. But they're given in answers in newtons. You can identify this kind of confused question. So option A, minus 0.4 newtons. Option B, minus 0.04 newtons. Option C, minus 0.004 newtons. Option D, minus 0.0004 newton. So how to solve this? You can see that they're given in that centimeters per second. We have to convert into meters per second, then we need to solve this. As you know that u is equal to 20 centimeters per second, the velocity of a final ball will come as 10 seconds. So it takes time 10 seconds. Okay? Yes. Is it Chandrayaan? Newton's third law of motion. Everyone easy you can able to recollect. Why? Because every time practically we are seeing this. What is Newton's third law of motion? You can see this gentleman. He is running on the boat and he kicked the boat. While he kicking the boat came backward direction, but this boy came forward direction. Here you can understand that yes, there is an action and a reaction. Okay. Now rocket launching. Air will comes down and rocket will go stop. Again action and reaction. In cannon you can observe, cannon comes back and ball will move further. Again action and reaction. Understand? So what is Newton's third law? Hope probably we can able to understand now. Every action is an equal and opposite reactions. Action is equal to minus reaction. Whenever one body exerts a force on other body, the second body exerts an equal and opposite forces on the first body. Or to every motion there is an equal and opposite reactions. Let's say there is an activity of third law. We can take two children and stand on the separate carts. So give them a bag full of sand or any other heavy object to ask them to play. What happens? The boy is throwing the sandbag on the girl. So both are in the cart. So they can able to move easily. Here in this case what happened? When a boy pushes the bag towards the girl with a force F, the bag also pushes the boy in opposite direction with equal force. So the boy also goes back. Of course girl will goes back while holding that. Now when the girl catches the bag, she also applied the force F to stop the bag. Hence bag also applied the equal force in the opposite direction. Fine? Yes. Next one is conservation of momentum. What is conservation of momentum? You can see that. Conservation of momentum. Momentum can never be created nor be destroyed. It can only be transferred from one body to another. Or when two or more bodies acting upon one another, the total momentum remains constant, provided no external force acting on it. Now you can see that suppose the two bodies having A and B, which is the mass m1 and m2 respectively. Here we will see that I'll explain in a different way. An object of mass m1 going with velocity u1. Another mass of object m2 going with velocity u2, that is initial velocities. So when mass m1 will collide with mass m2, which condition? If u1 is greater than u2. If u1 is greater than u2, absolutely mass m1 will collide with mass m2. So both masses will be collide. Okay. At the time of collision, mass m1 is applying force on mass m2, that is F12. At the same time, m2 ball also applying the force on mass m1, that is F21. After collision, what happens? Mass m1 mass m1 will move with velocity v1 because velocity will be changed. Mass m2 moves with velocity v2. So this will happens. Again repeating. Mass m1 and mass m2 both are the different masses moving with initial velocity u1 and u2. Okay. So if u1 is greater than u2, exactly mass m1 will collide with mass m2. At the time of collision, mass m1 is applying force on mass m2, that is F12. At the same time, mass m2 also applying force on mass m1, that is F21. After collision, mass m1 is moving with final velocity v1 and mass m2 is moving with final velocity v2. Now, as per the momentum formula, momentum P is equal to mass into velocity. Mass into velocity. So let's consider left hand side, these objects are before collision, right hand side after collision, at the center one at the time of collision. Let's compare like this. So before collision, momentum of mass m1, let's say m1 u1. Before collision, mass m2, momentum m2 u2. So after collision, mass m1 momentum m1 v1 and mass m2 momentum m2 into v2. So before collision, after collision, momentums are equal, and at the same time which is in opposite direction here at the time of collision. As you know that F is equal to mass into acceleration, so mass into acceleration is nothing but v minus u by t. Here mass m1 v1 u1 we can write. At the same time, right hand side, again F is equal to m into a, once you can apply, again m2 into v2 minus u2 by t. Let's say this is F1 before collision, after collision F2. So F1 is equal to minus F2. Yes. Now F1 value how much? m1 into v1 minus u1 by t is equal to m2 into v2 minus u2 by t. So tt will be cancelled. You can multiple now. m1 v1 minus m1 u1 is equal to m2 v2 minus m2 u2. Now m2 u2 take left hand side. m1 u1 plus m2 u2. This m1 v1 take right hand side. So m1 v1 plus m2 v2. Here this minus will be nullified over here. We can able to take a common and we can able to shift it. Fine. So this is law of conservation of momentum. Hope all the children understood about force and laws of motion. Now take a big rubber balloon and inflate it fully. Tie neck using a thread. Also using a adhesive tape. Fix a straw on the surface of this balloon. Pass a thread through the straw and hold one end of the thread in your hand or fix it on the wall. Ask your friend to hold the other end of the thread or fix it on the wall at some distance. This arrangement is known as, you can see in this figure. Now remove the thread. If you remove the thread, what happens? Automatically air will comes out and balloon will goes other end. Okay. Now, does the straw move? If yes, then which direction? Yes, straw moves. The straw moves in the direction opposite to air exit. Why does this happen? As the air filled in balloon exists from a nozzle, it has some mass and velocity, hence momentum. Now by laws of momentum conservation, to balance this momentum, balloon has to move in opposite direction. At the same time, take a test tube, fill the water and cork it. Heat it. What happens? Due to water vapor inside of the test tube, the cork will comes forward direction and the tube will goes backward direction. Again, this is the best example of action and reaction. Alright. So here you can see heating the test tube causes the water to vaporize and creates pressure, which marks cork blowout. Blown cork has some mass and velocity, therefore it possesses momentum. As you know that momentum P is equal to mass into velocity. To balance this momentum, as per law of conservation of momentum, the test tube recoils the direction opposite to the cork. Alright. Let me see what you understood. There are very important questions over here where the CBSE board or the teachers will ask us number of times. Let's try. A bullet of mass 20 grams is horizontally fired with the velocity of 150 meters per second from a pistol of mass 2 kilograms. So what is the recoil velocity of this pistol? The bullet of mass 20 grams is horizontally fired with the velocity, which means let's say m1 is the bullet mass, m2 is the pistol mass. 2 kilograms convert into grams, so which means into 1000, which is 2000 grams. Why? Because mass m1 of the bullet they given in grams, so all are into uniformity. So the bullet mass with the velocity 150 meters per second, let's say u1 is equal to 150 meters per second. Now they are asking about the recoil velocity of a pistol. So mass of a pistol is 2000 grams and u2 value we have to calculate. So this is the way we need to identify. Next, formula. As you know that m1 u1 is equal to m2 u2. From that u2 value we can able to calculate. So u2 is equal to m1 u1 by m2. If you do that, you will get recoil velocity minus 1.5 meters per second. Clear? Let's summarize what we discussed. Yes, there is a mind mapping over here. We saw that in laws of force, yes, we saw that what is force and types of forces, balanced force, unbalanced force. Then after we studied Newton's first law. Newton's first law indicates inertia and Newton's second law indicates momentum. Newton's third law, every action is an equal and opposite reaction. Clear? So we solved number of numericals in this session. Thank you so much audience for joining, and every day we can meet 10 to 11 with number of numericals problems of class 9 standard, then 10th standard, continuously 11th and 12th, daily 10 to 11 p.m. And who not subscribed, subscribe my channel. And yes, feel free to ask the questions. In the description there is an email ID, you can able to contact me. And there is a Telegram channel. I am giving that written notes to all the students. You can able to utilize it, especially the rural country, village background students where they're unable to reach the sources. Yes, I'm live. Thank you so much for joining us and enjoy the day. Good night. Jai Hind.